Computer. Okay. We start officially now. You can say profanities because now it's not on streaming. So I will not apply any special censorship. Welcome, everyone. This is the last official event of the Transform 2020 conference, and then we conclude this with the hackathon presentation. I don't have really much to say besides that this, I think, was a great week with a mix of hackathon tutorials and session and lightning talks, which we hopefully be able to replicate sooner or later. We had 13 projects. A couple of them decided not to present, so today we have exactly 10 presentations, which and we have a presenter which will be able to present for 4 minutes each. And then we'll have a break in the middle, stretch our legs, get some coffee. I shared a group map link on the Hackathon channel, which I will kindly ask you to open so you can provide feedback to the various projects. I know the presenter should be already, and I know that Rob, which is also here, sent you a message, and I probably will make sure you are ready to go. The agenda is also shared on the Hackathon channel. And yeah, I guess we'll just start, and then we'll leave everything, any questions or whatever, for later. So the first project that will be discussed and presented is the 52 Things project, and I think Matteo should be ready to go. Matteo, are you there?
Yeah, I am.
So I think you probably want to share your screen, and also kindly ask everyone to mute their microphones. And you have your timer?
I got a timer.
Okay, whenever you're ready.
Okay, let's go. Okay, so that's the title of the project. We wanted to edit 52 things you should know about geocomputing, the next installment of the 52 Things series of books. You can see the previous ones by Agile. And my apologies, I just realized I didn't put a full list of the participants. But you will see in the chat that I screen captured. This is where we started. We had as a goal to review as many chapters as possible. And I prepared this spreadsheet ahead of the beginning of the hackathon. We had all the authors and titles of the papers, and the main thing was this status column where we had the status of the paper not looked at, needs editing with input from the author, etc., etc. So we wanted to get as many of the zeros and ones, and this 1.5 was a bit odd, but two or three during the project. And so, oh, wow. Talking about presenting with Google Sheets. Okay. Is that on my side or? Okay. That's great. Maybe I will go out of presentation mode, I guess. No. Okay. Can you still see it?
Well,
so we had a first weekend very active on the channel. Lots of messages. We added some new things like tags, word count, extra comments and even quotes. This is to help at the end with the final process. We had a lot of issues open. We were tracking this way the reviews during the weekend and during the week as well. The second weekend, we had a few last-minute claims for papers that weren't read. And we had a whole bunch of, during the week, I would say about 15 reviews started, and some of them closed as issues. And this is where we got. I have on the right that status that I showed at the beginning, and we got some papers up to ready for layout, and most of the ones that didn't have a review reviewed. So really exciting. And this is just my concluding slide. Was it a success? I think so, definitely. I think we got a much better response and a lot more work done than I expected. But it's not over. You might still be able to help. There may be a sprint, but certainly, even if nothing officially happens, I would say there's room for a few more chapters to be read. And take a look anyways. There's some really interesting articles there that are worthwhile reading, even ahead of publication. And that's it for me.
Filippo is muted.
Now I'm unmuted. Thanks, Matteo. Usually it shows that you are muted, but not always. Thank you, Matteo. Please do not forget the group map, because then I think we'll be able to share it with everyone, so you can get some feedback for your work. So the next in line is actually so it's the Wellioviz and dash, right? So Doug, I think you're next in line.
Yep.
Yes. You have your own timer ready?
I'm ready to go. Yeah.
Yes. So it's all yours.
Perfect. Thank you. So hopefully you'll see my screen in a little second. So our project really was from an idea that was started by Tony Hallam pre-Hackathon, which is all based around trying to make a dash app to show some interactive well log visualization. So I guess first of all, I'd like to give a big shout out to all the people involved. So there was Kent and Wesley and Michael, Beiruz, Julio, Rennie, Brian, Kieran, John. So we had a really big collective effort over the last couple of weekends. And considering not many of us had any Plotly or Dash experience before we started, we've kind of got to that MVP that Matt and Brendan talked about, which is we have on Heroku a Dash app live, where we can now interact with some well log data. If I choose the pan option in here. So we've loaded one of the Poseidon wells from the Data Underground open source well data. We've now got the ability on this plot to choose which of the wells we want to show on these tracks. We've got an ability to zoom in on here, which has got a multi-scale zoom across all plots. And then obviously, again, like I said, the ability to scroll up and down across these. We have a cross plot as well, where we can choose which things we want to put onto that cross plot. So in this case, I can do a VP versus density, let's say. Where's my density on here? So you can change the things that are in the cross plots. We haven't quite got the interactivity between these two things together, but the next step is to plan to have the ability to link selections from the cross plot that will then show up across there onto the well tracks as well. We also have been working on having a multi-well selector in here with some issues with Welly being able to get a data frame combined from all the well data with the right well headers and stuff. We had a last minute fix to that this morning, but we haven't quite managed to get it implemented on the on the Dash app. But overall, we're really pleased with the progress we've made. Like I say, we've been able to now make an application which we've got all the way live from Dash up into a Heroku and live online. I've actually posted the link for this onto the Swung Hackathon channel. So if anyone wants to have a look at this, you can actually follow the link live and go and have a look at this app and give us some feedback on things you like, things you don't like, things you'd like to see added into it, things that you think we can improve on. And I guess that's pretty much all that I've got to show. Just short of my 4 minutes, Filippo.
There you go. Thank you very much. It's really cool stuff here. So, yeah, guys, you definitely think your project and Segway Swiss Army knife were definitely the most active on my Mac. It was like popping up messages every 2 seconds, which I thought was really impressive.
Oh yeah, it was great because we were literally all over the world.
Yes,
so we had like 24-hour round the clock people doing stuff in the project over both weekends, which was pretty awesome.
Yeah, I think yours and then the Wellioviz also, they were like a fair amount of time zone, so it was also quite impressive. Cool, excellent. Let's move on. So actually next one, I have a video for that because I think Jared is probably in bed by now, or yeah. Jared, are you here? I see you.
I am. I couldn't resist.
You
show the video anyway.
Or shall I go with the video?
Yeah, go with the video.
I go with you. Okay. Okay, so Jared prepared a video because he's 10 hours ahead. So he sent me a really nice video. So I'll play it on my computer and share the screen. Hopefully the video will go through, I don't know how, from the speakers to the microphone. So let's do this. Okay, let me first share my screen. It's this one, right? Yeah. Then, so you always see this, right? Okay. And let's go.
Welcome. Hi, everybody, at Transform 2020. Welcome to the closing talk for our Hackathon project. Our project was about encoding continuous wavelet transforms to estimate coal lithology boundaries from downhole geophysical logs using only Python. The image here is only based on the synthetic log to the left. My name is Jared Armstrong, and our team included myself, Leo Denendra, and Martin Bentley. You can read a bit about us here while I'm talking. A bit of background on the project. A couple of days before this conference, I read Evelyn Muirhill's paper. I thought, wow, imagine if you could successfully do this in the coal sediments by just pressing a button. You can find references to some of her papers in the Slack channel. Anyway, during Filippo's welcome address to the hackathon, he encouraged us all to sit into a project if we had an idea. So I decided, well, why not? Let's have a crack. The project got launched. This is a gamma log. The first 2 plots are the full hole. The last 2 plots are the bottom 150 meters of the hole. You can see the difference between the raw and the conditioned logs. I want to talk a bit about the process. Firstly, we realised that the raw logs were visually too busy. After playing around a bit, we log conditioned using the SAP-Gold filter, you can see on screen. And later, we switched from gamma to the density log. Some of the libraries that we ended up using are also on screen. Secondly, we, or rather Leo, successfully generated the CWT plot, yay, on the left, and the boundary strength plot was on the right. This is the only bit of code you're going to see in this presentation, so savour it while you can. Finally, the mosaic plot, yay! Clap now if you like. First is the gamma, second is the density or rho V. The black arrows point to the coal seam. Unfortunately, we found the visual correlation between the gamma and the lithology to be fairly average. Correlation seemed to improve with density, but ultimately we needed to try multi-scale correlation, meaning combining both logs. Try again. Martin built on Leo's excellent work and added some interactive slider widgets, which I'm going to show you now.
Okay, let's have a look. So what we can do is we can now change our top that we're interested in. So we can do that. We can also adjust how sensitive we want to be to boundaries. So what we'll do is we'll look for, stronger boundaries there, and we can also resample the curve, which will take us slightly less stuff. So this will look for only sort of the really strong boundaries. So you can see that we've got a fairly nice correlation here at the base of the coal seam. We've got another one maybe a little bit higher here, but we've got another one here at the top of this coal seam. And actually, if I go a little bit further back, you'll see that we actually are missing this one here, and we're missing whatever that is. But still, that looks pretty neat from my side.
Final wrap up. In terms of future work, there's much more that can be done here to further mould these initial concepts and code them in more useful features. But in conclusion, we think that tessellations rapidly and reproducibly resolve subtle and subjective details of coal blocks and other geological domains. Obviously, it's still into the work. We think the technique should therefore be considered an important addition to the mining and exploration geoscientist toolkit. We also think that this would be a handy little plot to include in something like that, probably their subplot features. So, on behalf of the team, a massive thank you to all that have been involved through the week. Thank you to the organisers of the T2020 conference. Thank you to Filippo for his guidance. Also, folks like Doug MC for generating the energy, help us get along. Brendan, also thank you for some of your technical input. And all of you others who have contributed in some way to this project. We thank you very much. Finally, to the Software Underground community, we bequeath to you code, the ideas, and that gorgeous mosaic plot generated by our team. That's it. Good night.
Okay, we're back. Thank you, Jared. Also, thanks for staying up till quite late. Okay, next in line is the GemPy geographic group.
Yep.
Two
are
names here. Oh, no.
Arthur has had to drop out since his microphone or sound doesn't work properly.
Yeah, I don't want to risk what happened during the lightning talks on Thursday. So
okay. So who's presenting?
I will present.
Okay. Whenever you're ready.
All right, 4 minutes from now. Yeah, so welcome to our little presentation here. So we are the GemPy geographic group, and our project was to basically create a model with GemPy based on interactive selection of points and cross sections. So the geology, or the let's say the project we took is located in here. So that's actually a picture of my master thesis a little bit. So the aim was to basically reproduce this little syncline here that you see. Okay, so what did we do? We loaded the data first. So here the geological map again with geopandas. We also loaded a DEM so that we can extract height information of the selected points. Then we just played a little bit around with the hill shades here. But the main point we want to emphasize on is here this interactive plot that we did. So what can you do? First of all, you can interactively select a model frame. You can also edit a custom cross section, for instance, and most importantly, you can add points. So you can just click here, make some points, and then those points will actually show up down here in a table, where you then can add the formation name, and if you have orientations, you can add dip and azimuth values. if we scroll further, here just an image that we can, that you can see we read the data points that we clicked. We also have the cross section in here. And the final result after getting the altitudes from the DEM is basically a pandas data frame that can be just read into GemPy. So then let's create a model. We have, of course, saved the data frames before that we don't get into any trouble here, but we can just quickly run our model. So we can see we actually digitized 2 layers. We have one's Carboniferous and one's Devonian. So if we look on the map here, on the plot, then we digitized those points here. So it's just a few points, 3 orientations. We have the topography loaded. Then the Yano function, that went quite smoothly. Model is computed, and yeah, you just saw it already, and we basically get a nice synclinal structure here, what we actually expected. We can also plot the geological map here. It seems to be that the map is somehow turned around and doesn't fit properly to the points here. But most importantly, we also create a 3D model. So, and yeah, if you compare that maybe to the geological map at the beginning, let's take this here. I think it looks not too bad for just digitizing a few points. And yeah, so that's what we have been doing. So Arthur, he was mainly working on the interactivity. I was in charge of the, let's say, getting things into GemPy. And yeah, what's next? So for the future, maybe we can even implement that in Dash. Oops, that was my timer. Yeah, implement it in Dash. We want to add some more function, and I think we can also put it maybe in a full feature package that can then pass information to GemPy, such as the CRS, extend, and most importantly, the data like interfaces, orientations, even the stack and the custom sections. So yeah, we're happy to get any feedback from the community, and also thanks again for organizing the Transform. And yeah, then back to you, Filippo.
Thank you, Alexander. It was really cool. It was a nice comment by Brandon in the chat. It was emphasizing that there's a lot of interactive tools that's been used and shown in the last project. Cool. Then we don't forget group map link. And I think next in line, we have the segysak in Tony. Is here, right? And then after that, we'll have a 5 minutes break. So whenever you're ready, Tony.
All right, just share the screen. All right. I'll probably go over time, so start with acknowledgements. In the team, we had Steve Purvis from Tenerife, Fabio Conderas from Madagascar, Hai Strathoff from the Netherlands, and also Alessandro Amato del Monte from Milan. And our project was basically about trying to boost this package. And segysak is kind of a package designed to make it simpler for people to get seismic data into Python and to manipulate it. And it does that in 2 ways. One, by leveraging the great work by Segway.io, but secondly, by more easily loading that information into Xarray and using the native Xarray dimension labeling to allow you to do special things, or at least to do more easy slicing. So we had a few objectives this week, including getting the package up on PyPy and expanding the documentation. both of those things have been done. So you can see the read the docs documentation up here at the moment. Still a long way to go, but definitely much more than where we were kind of with a fledgling project at the start of the week. We've also spent a lot of time fleshing out the examples, and all of these examples have been basically built directly from notebooks. So we've been trying to build examples that allow people to see how the package works, get a little bit of familiarity with Xarray and the .size namespace, which we built for ourselves under the Xarray name. And some of the cool features we've got, you can now do basically dimension-based selection. So you can select on the eyeline and cross-line names or at a two-way time value rather than needing to know the indexes associated with these. We've got improved tools to help you handle your segue headers. So you can bring in just quick header scans if you want to know what your byte locations are like. You can look at all the header information as statistics. You can load the raw header information in just to give you basically a data frame of all that information in the headers, and then you can QC it to make sure you're loading the right positions. We've got some examples here for loading horizon information in and then interpolating that back to your seismic data, as well as attribute extractions using that information, including structural slicing. And we've also added tools to help you build arbitrary line extractions or well trace extractions, for example. We've been using, basically the vulva data to help us test this. You also saw earlier in the week, the lightning talk, that we can kind of integrate with Dask. So that example's up here as well now. If you want to do sort of bigger projects with large cubes, then this might be the way to do it. Finally, we got a bit of a CLI. So you don't even have to come into the notebook if you want to convert your data to the NetCDF format, or just look at your seismic headers or the text header, for example. You can use the command line tool. So what's next? Well, there's obviously a lot to do on this project. So if anyone feels like they want to contribute or try out some of the examples, that'd be great. Otherwise, big thank you to the project team for everything they did during the week. And it's just amazing how much this project has grown in just a few days. Cool.
Thank you. I think we have a message. Thank you, Tony. A message from Matt about the group map. Okay, so yeah, for the people that are doing the group map, please read the last message from Matt. Otherwise, assume that your comments will not be saved, right? Okay, let's take like 5 minutes break. Some water. The next line, I think, is the seismic processing project with Alan. We'll supposed to start at 4:50. So yeah, let's be back in 10 minutes. Or I'm not going anywhere, but I'll definitely get some water. It's a good time maybe to fill out the group map if you have not done yet so. Just want to also take time to say a few things about the channels that have been created during the transform. There's no final decision yet, but definitely would be recommended to gather all information you need from those channels, because I guess eventually, not within the next weeks, but maybe like in a few months, we would like to archive what is possible to try to keep the Slack workspace fairly clean. Or if there's a necessity, transform the channel to non-T20 based channel, because that might be the case. Because I don't see, why the segysak, for example, should not have its own channel, but it's a decision that shouldn't be made by me. But again, it's something definitely I recommend. Of course, there's a hope that or desire that you guys will keep working on these projects. So if a channel like that is the way to go, I don't think you have the chance to rename it, but you can ask me, and then I'll simply rename the channel if it's needed. So please also to approach me or one other Matt or someone else from the organization to do so.
Definitely be helpful to keep the channel going. I think it's got a lot of history in it now that.
Yeah, it's for sure something that's not any short-term things that will be made. But eventually, the number of channels, again, the number of channels Slack is already here, is already getting out of control. So I think it's.
You could do a rename as well and just have it, segysak channel for segysak.
Yeah, that's what I said. Like,
ongoing.
For example, like if segysak, will hopefully stay active and so on, but maybe the other ones they also feel the need to maybe wrap up and move somewhere else. I mean, that's a possibility. But again, it's not like any decision that will be taken really quickly, so there's no rush. Maybe in a couple of years when we have a T20, T21, and T22, that might get a little bit out of hand. So. Was there anyone up yesterday very late for the 23 UTC Hackathon catch-up? I think I saw Will chance here on the name list. And Will, I see you.
Yep. We were there. Justin was there. Matt. Sorry, Michael and Martin. Yeah, we were all there.
Cool.
Had a good conversation.
You got 50 people today. Okay, pretty good.
3 out of the 4 people on that call yesterday afternoon were within 5 miles of each other, and in Houston, and then the other was in South Africa.
Cool. So, as anyone has a fan fact, funny story to share with us, about the conference? Something, maybe not code related. I don't know. No funny happening. Just coding.
Just coding, just sneaking around, trying to code without people noticing.
Without
and trying to avoid real work and code on fun projects.
They're like coding from the toilet. You're just like, yeah, I'm going to the bathroom. Like 1 hour later, you hear like yeah.
Maybe the alcohol rub for your laptop, maybe. Yeah.
Hey, Steve, you have a quite impressive setup in your computer-wise. That ginormous thing. You posted some pictures.
In the office, yeah. It's a bit of a yeah.
Is that like your
I
heater?
don't have any health and safety advisor, you see. So
Yeah.
that's why there's cables everywhere.
You probably don't need a heater there in Tenerife, but like that's probably that would have that function, right? Just warming up the room. Maybe you cook steaks on it. You just put steak on top and then.
Yeah. They're not too bad. I bought one of those big double-sized boxes. You know, like so they're two like. It's who's it? Corsair makes them. It's like they're like 2 PC boxes worth PC box.
Oh, yeah.
And
Yeah.
that keeps everything nice and cool.
Okay. And then, yeah, you know, if anyone is still willing to share a couple of, you know, like pictures or something, you know, some nice selfie work setups, then would be nice so we can put them together. And like in the previous years, we have a nice gallery, maybe on Google Photos on our last Met, if there's a Software Underground gallery, so we can also have some photographic memory from this this conference too. I see that one is straight here. And so since you're here, we'll follow up in, guess, a couple of ways, so Slack, and probably also through an email from SCAD. We'll send out a request of feedback. I'm not sure yet. It could be, you know, some kind of surveys, Google Forms, or group map. So if you see an email from us in the next days, please don't trash it immediately. Please open it and have a look. There will be most likely some kind of link for survey or not tutorial. Form feedback, and we definitely will highly appreciate those, because there is definitely lots of things that we'll like to improve and do differently next year. And we definitely welcome very much your feedback on that. We definitely need to do much more to welcome people that are more on the beginner side for this kind of events, because definitely here the remote component, the online things was probably more difficult for people that were not used to this kind of events. So we definitely need to do better for that. Also happy to get suggestions regarding technology tools. I know I saw a couple of posts with people very enthusiastic about Miro.com, used as a whiteboard, dashboard, remote, like collaborative one. Since a group map here, it's been really well received to get feedback, interaction. So anything that I know that Dieter and the Gostin group use the hackmd.io for sharing notes online in a collaborative fashion. So if anyone has suggestion when it comes to tools, technology, better alternative for anything, please don't hesitate to share those with us. Message here. Yeah, that's I see it's a message on the channel, with that says, you know, that it would be very good to have a longer introduction to GitHub and Hackathon's work. And yeah, I think that's definitely something we kind of we were not up to the right level this year, and yeah, we definitely need also to figure out how to do that such that everyone is able to participate. We got some feedback regarding that, so hopefully we'll be able to make things smoother next year. But I think it's almost time to go back to our presentation. Yes, 4:50. So I think I see already the presentation has been shared, the screen has been shared. Are you Adrian?
Yep.
Yeah. So I think if you have your timer for minutes go, then it's all floor is all yours.
Thank you, Filippo. So my project was to try to make it easier to use some basic seismic processing tools from Python. The original plan was to try to wrap some of the tools found in CPSeis, which is a large and pretty high quality code that was very generously open sourced by ConocoPhillips, but which is unfortunately a little bit difficult to use, firstly because it's somewhat troublesome to compile it, and second because it uses quite an ugly Java GUI. So I wanted to just extract the useful processing tools from that and then wrap them in Python. Unfortunately, it turned out to be quite difficult to get pip to compile the CPSeis library as well in a portable way. So eventually I abandoned that plan and instead wrote several processing tools in pure Python. I actually used PyTorch's torch script to write the processing tools, which means that they are JIT compiled, and so hopefully you still get pretty good performance. And it also means that they can run on both CPUs and GPUs. I've written 3 tools so far: time frequency clipping, FXDecon, and AGC, and you can install the library using pip install, and since it's pure Python, hopefully it should work well for everyone, although you might want to install PyTorch first if you don't have it installed already. So let's have a look at examples of applying these 3 tools to some real data. Here is the real data that I'm going to apply it to. It's quite nice data, it's marine data, but you can see there is some noise in it, and we'd like to use the tools that I developed to remove some of that noise. So here is after applying time frequency clipping. The time frequency clipping is, or variants of it are sometimes known in other processing packages as FX denoise. It's a way of trying to remove high amplitude isolated noise, and you can see it's removed quite a bit of high amplitude noise here without affecting the signal. The next one is FXDecon, which is the most popular method for removing noise, I would say, and you can see that in this case it also did a very nice job. So here was I took this output from the TF clip and then put that into the FXDecon. So this was the output from TF clip, and here's after FXDecon. So it really removed a lot of noise without apparently affecting the signal. And we can then compare this with the original data. So this was the original data. Here's after applying those 2 denoising processes. And you see quite an improvement, but the signal looks like it has been preserved. So then the next tool was AGC, or automatic gain control, which is for boosting amplitude in weak areas. I would say it's probably not typical to apply AGC to raw data like this. You would more typically apply it to a processed image so that you can focus more on the structure of the image rather than the amplitudes. But just as an example, I will apply it to this data. And here's the output after AGC. So this was my input to AGC, and here I've applied some amplitude clipping because there are very large amplitude variations across this data. This is very high amplitude, this is very low amplitude in the weak areas. So even though I've applied some amplitude clipping, so there is some distortion of the high amplitudes, you still can't see all of the weak amplitudes. And that's AGC should bring up those weak amplitudes so they have more comparable amplitude with the strong amplitude, so you can see them more clearly. And you can see it's done that. So, I mean, there is still some residual noise in this data, so you see that more clearly as well. But the thing we're looking for is that you can now see this very weak signal down here. So AGC seems to work quite well as well. So those are the three processes I've implemented so far. I do hope to continue implementing more of them in the future. If anyone wants to contribute, you're most welcome.
Perfect, Dan. Thank you very much. Thank you. We move on, and then it's, where is it? Okay. Okay, we have the Artash. Right, you're there, yeah. So is the which worked on a project to understand impact on of the various COVID-19 related lockdowns and the impact on seismic vibrations. Ash, where? Oh, there you are. Good. You ready to share your screen?
Yes, I am.
Excellent. So whenever you're ready, we are ready.
Great, thank you. I'm Artash, and I'm a grade 8 student from Toronto, Canada. I'm interested in space, robotics, machine learning, and seismology. My project is called Signals of Silence, and my goal is to observe the impact of the COVID-19 lockdown restrictions on the seismic activity in Canada. Now, to do this, I decided to choose 6 cities to measure in 4 provinces of Canada. These cities are Calgary, Montreal, Toronto, Edmonton, Ottawa, and Yellowknife. Now, to get the seismic vibration activity data from these cities, I use data from IRIS, the Incorporated Research Institution of Seismology. The files I downloaded for each of the city were mini seed files, which contain the waveform seismic data. And to download and process this data, I used the Python library obspy. Now, these mseed files gave me the raw waveform data, but I needed to process them because, in fact, this data was coming at 100 readings per second. And for over 6 months, this comes to over 1.5 billion lines of data, which is way too much to analyze. So the first thing I did was break it down into 15-minute periods, as you can see in the first graph. But there's still way too many fluctuations to see any trend line at all. So I break it down even further into the average seismic activity per day. And this is the second graph, and you can actually start to see some kind of a trend here, but it's not clear enough to pull some clear conclusions. So the last step I did was to clump this data up into 2-week averages, as in the last graph. And this, as you can see, gives a very clear idea of the trend of seismic activity over time. Now, here's the first city, in Calgary. And I observed a 31% decrease in seismic vibrations during the lockdown. In Edmonton, we measured a slightly less 14% decrease in seismic vibrations. In Montreal, we observed a 34% decrease in seismic vibrations. And in Ottawa, it was slightly different. It was an 8% increase in seismic vibrations instead of a decrease. Now, Toronto, where I live, there was a 34% decrease in seismic vibrations. And in fact, between these 2 orange lines you see, that's the period of the lockdown. Finally, for Yellowknife, which is a bit up north, there was a 44% decrease in seismic vibrations, which is the most I've seen among these 6 cities. So in conclusion, in these 6 cities, we saw a decrease in seismic vibrations in 5 out of the 6 of them, not in one of them where it stayed around the same. But there are many limitations to this project still. For example, this seismic vibration I observed was only for the HSZ channel, which means I only took vibrations on the Z-axis. And in fact, I was wondering whether I should use vibrations in all X, Y, Z, all 3 axes, but I was not sure. So I would appreciate any suggestions on which axes should I collect on. Also, not all the stations I collected data from were inside the city. Many of them were a little bit in the outskirts of the city. And finally, these lockdowns were not uniform in all these 6 cities. For example, some cities may declare public health emergencies, but some of them may implement hard lockdowns where they shut down everything, but some of them may only prevent group gatherings. So these lockdowns are not very uniform here. Thank you, and if you have any suggestions on what I could do to improve this project, I would greatly appreciate it. Thank you.
Thank you very much, Akash. This is really amazing. We really happy to have you here presenting this. Okay, Frizo, where are you? There you go.
Do you hear me now?
Yes, we do.
Okay, great. Everything disappeared when I shared my screen. As usual, I'm not very good with technology. Yeah, just a quick overview of my project. What I did is implement a few functions out of the book of Zobek, geomechanics, kind of lining them up for possible use in the Bruges plugin. I was reading the book while I was doing the hackathon, so I thought it would be nice to combine those 2 activities. I want to thank, before going into this, I want to thank the organizers. I also want to thank Avis Popula for testing and using some of the code during this project. You can download it here. The short summary is created a function a day. Density to stress, integrating density log stress to effective stress, the probabilistic strain equation, stress polygons using Zobekograms, and conditions for tensile fracturing and well breakout, and then a method to squeeze polygons. I would just quickly go over the functions and what comes out of it. Loaded the Barnett data. That's publicly available. Just integrated that, created pore pressure, effective stress. There you can plot the stress. Profiles against depth. Made them a little bit more interesting by applying an overpressure here. You see that here with effective stress becomes approximately constant, and the pore pressure goes approximately parallel to the lithostat. Then using the polygon functionality, you can make Zobekograms. That is basically given a vertical stress, the allowed stress states in terms of horizontal minimum stress and horizontal maximum stress in the subsurface, assuming that the crust is pre-fractured. You can see that it increases quite a bit when you have a normal pore pressures, but that area gets constant when you get into overpressured areas. Tensile strength, tensile fracturing conditions are included, and you can apply those to the stress polygon, so you can squeeze the stress polygon with these conditions. You can do the same with breakout conditions. And again, using some uncertainty from the breakout conditions, you can squeeze the stress polygon again smaller, and you end up with a quite narrow estimate for what horizontal minimum and maximum stress you can have. So that's implemented. There's a lot more to do. Testing, maybe some paper reproduction, book reproduction, adding it to the Burgess master branch, and then a lot more geomechanical functionality that's available in Zobek's book and elsewhere that can be implemented here as well. That's it. Thank you, Filippo.
Thank you very much. It was really cool too. There was a comment by Matteo in the chat. Some really excited.
Thank you.
About variable inspect. What is? Oh, that thing. Oh, that. Okay. Is that a Jupyter notebook feature? The variable inspector should. The variable thing, the value of the variables. This is it's the Jupyter Notebook widget or something like that. I've never seen that actually. You hear me, Friso? Yes.
Sorry?
Yeah, like the variable inspector on the right.
Oh, yeah. No, it's the first thing that I looked for. It's I was always a MATLAB user, and there it's very easy to see what variables you have in your memory and what shape they have and what value they have.
But it's
I struggled a little bit with that, and so I found this. I don't know where I found it. It's a long time ago, and since it just has been hanging out there.
Okay, well okay. So Matteo is typing, probably giving me the answer. But let's move on. And I think Dieter.
Yes.
Can't wait to tell everything about.
Let me see if it works. You can see my screen.
Your open source tiny project.
Yes, I'm good to go. When you are. Yeah, Filippo?
Yeah.
You hear me? Cool. So Gostin, made up title for Geo open source tie-in, mainly because I couldn't come up with a better title. It was about a week before the hackathon, and Philip said, "Hey, when is your project coming?" And I said, "I don't actually know. I just know Miguel would like to do something, and Simpeg would be interested in." And because we started 1 year ago at Transform 2019 to try and bring together a bit more these different communities. So yeah, that was the name I could come up with. And then I had actually no clear idea. I just thought it's the honeypot or umbrella to capture anyone interested in doing non-seismic stuff on the hackathon. And then I reached out to a few communities, and we had a pre-hack meeting. And yeah, I think I was blown away by what happened, and I'm really happy. And I just have here a list of things with some images that I go through. So some resources, including this document, if you want to read it up. If it's maybe too small now, I can try to make it a bit bigger. hackmd.io at prisa/summary. And there will be the brainstorming we had, the meetings we recorded, the Miro board Filippo mentioned, and the repos. So the idea was part one, we do case studies. Anybody that would like to use one tool, say Simpeg, and take some results from there and go to other projects like GemPy or Fatiando to try and do that in a notebook and see what works, what doesn't work, and what needs improvement. And then the part two would be to see how can we do these improvements. There's a few numbers in the Slack channel. We were 55, we are 55 by now. Here are a few names of guys who did really a lot, Miguel, Wayne, Dom, but many more jumped in. So I think about 15, 20 were really active. These are the communities that are really involved: GemPy, Simpeg, PyVista, Fatiando, PyGimli. We hope to get them also a bit more on board, but also Map to Loop with Mark Cheslos here, and we had some experts for the open mining format that we might use later on. So part one, we were hacking on different projects. So we got an environment YAML in the Gostin repo that actually could install in the same environment all these projects, which is quite a difficult thing at times. Docker file for the same. We could fix some Travis issue with GemPy. And just today, Andrew got actually GemPy into Conda Forge. So we can now install GemPy easier for the next time. Here's an example to get magnetic field measurements from Fatyander to GemPy, these dots. We had examples to go from GemPy, export a model and have it in a triangulated mesh in PyGimli. We had examples from Petrel to GemPy PyVista. And we had here some from Richard in Australia. He got some mineral classification into GemPy. These two notebooks really awesome to look up. And then Dom, this is analyst from Mira Geoscience and a proprietary tool. This is GemPy. This is a notebook, and these are all linked in the backend and work together now. A really awesome result that I think we can hopefully build on. And then we got together and start, how can we do that? Subsurface project. We said it doesn't matter how good it is initially, we just have to commit that we use it. And all the communities I mentioned, they committed to actually use it. So we hope we're off for a good start. And we hope to see lots back at Transform 2021 for sprints to fix issues and bugs and to get more communities into it. Yeah, I think that's me. The 4 minutes are up. But have a look at this notebook and you'll find lots of links in it, and I will post it in the channel, this summary here.
Thank you, Dieter. It's really cool stuff. Also, yeah, the Hackathon is really, really cool tool. I've started using it, and it's very addictive. Thanks for sharing that too with us. Cool. Well, want to go? The last but not least, as we say, the Wellioviz, which is also one of the most active and also most global project, together with the other, very JavaScript visualization oriented project. Cool. So whenever you're ready, we are ready, Justin.
Can you hear me?
Yeah.
Okay. Yeah. So so I'm gonna explain a bit about Wellioviz and what all the people on this project built over the past week. So it is a library for using D3.js to make prolog visualizations. And although Wellioviz is just the visualization component, the long-term vision is that it makes other things possible when it is combined with some additional code. And so a lot of what everyone worked on this week ended up kind of moving us a bit closer to these three goals. So one is a visualization library that could be built into websites, and then also a GUI so that non-coders can work with prologs and not have to install things or pay for things, and then also to have a way to do your prolog transformations and predictions in Python, which is better at that but then do the like visualization in JavaScript, where you can have very low level control of that aspect. So I try to kind of like map out here how all the different people kind of like contributed to these goals in a very kind of like broad sense here. So like yeah, go on next slide, and then I will do a live demo where I'm gonna go to the like website of the Kansas Geological Survey and visualize a well log without like downloading or installing anything on my local computer. So I'll leave presentation mode. The website of the Kansas Geological Survey is what I'm showing here. And if I copy a link here, go to this input form, hit apply here, and then scroll up. The well log is here. And we can also load it from a local file. So if I go to the section for that and choose a file, and then the window will pops up, and I can pick a random well log, and then it will be shown here. And you can also change all the configuration of how it's being plotted, because all the instructions are given to the like library as a JSON. So the plan is to kind of like build out a mapping of curve name to curve style, and then configuration variables for like curve styles, and because it's just a JSON, you can also download and then share and save those like curve styles, which like control how things are plotted here. And we used observable to prototype stuff like fast, but the plan is to build a more traditional like GUI web page like I have here, which like won't involve as much scrolling, etc. And there's like zoom and stuff like that built in as well. And then also I didn't have time to put this in this slide presentation, so I'll just move the window over. And Nathan got a minimal viable product version of like panel talking to Wellioviz as well. And I think I've talked for 4 minutes, so, or probably 5.
Cool. You can go on a little bit longer if you want. You're the last one, so you get this luxury to.
Okay. Yeah, sure. So like things like that were like started and talked about a bit was to like also extend what we have currently, and be able to do cross sections, and so like that work has kind of like started, haven't gotten very far with it yet. And then also, although I'm not like plotting anything here, it can also like show tops and rectangles as well. So you can start to kind of like fill it out to other types of tracks, not just curves. And there's also docs, which you can get to from the GitHub page here, which look like this. Does somebody have any questions?
Cool. Yeah, I really like this. Is I still have that page open in my browser. One day I will install it and play with it. I promise, Justin. Time has been limited. Cool. Thank you very much. Well, thanks everyone. We are now officially over with the presentations. I think it's everyone can agree that this was really cool and great stuff. It's over for now. I think everyone had a very good impression about this slightly different format with respect to the previous years. So I kind of, really looking forward to the next iteration next year. Thanks everyone for participating in this, for taking time away from their families and stuff and their commitment. I think it was really great. It was interesting to see how people were able to collaborate very quickly, very quick turnout on pull requests and stuff like that. Looking at the activities in the various Slack channel, I thought it was really impressive. As I said before, we have a lot of positive things that will stay in our memories. There's lots to improve, and when we say that we are really looking forward to hearing your feedback, we really mean it, not just a fake sentence that I throw around. So, just write to me or Slack channel or whatever you want. Follow up on the email, which I assume you receive within a few days or a week or so from SCAD, because we really need your point of view, and we want to know which things went great. We want to know which things did not go well at all. Suggestions how to improve, and really, we want to take this as a starting point to make something even better for next event. I really don't have much more to say. I want to definitely thank you, all the people that gave me a hand mostly for the hackathon part. So people such as Dieter, Rob, Will, and Chance for making sure to be present with me on the live catch-up here on Zoom. And then for sure all the other organizers that were involved in the tutorials and lighting talks and sessions. So you can see here Dan standing in front of me in the middle of my Zoom gallery for the tutorial, for the lighting talks. And Rob for sure did a lot of job. And obviously the dynamic duo Hall and Hall, Brandon and Matt. And we had like another person which was always behind the curtain, which is Victoria, which I don't think she's here, which definitely she deserves a lot of credit for the organization. No, there is no judging process, Brandon. I just couldn't figure out how to do that.
Yeah.
Am I missing anyone when it comes to organization that really did a lot of in the, let's say, on the make sure things work? I think I mentioned anyone that really contributed, let's say, on the organizational point of view, right?
Yeah, I think it's just amazing to me kind of what's happened over the past week, and what our conversations were when we were thinking about this, which we didn't start planning to have a virtual Transform week-long conference until we were into the COVID thing. We decided to make the hackathon virtual, and then we were kind of placing bets on whether or not AAPG was going to take place, and we're like, well, maybe this is a chance for us to do something on our own with Swung, and everybody stepped up to the plate. Like, this has been an amazing week of content and community, and seeing what we can build together during the week, not only from the hackathon, but people putting together tutorials and things like that. So it's been a long week and a lot's happened, and it's been fun to meet new people and see some folks that I haven't seen in a year or so since Transform last year. So thanks to everyone here for making this what it was. I think that, as considering what we just did as a minimum viable product, we proved some hypotheses that we can, as a community, put an event together where we all get a lot of value out of it, and actually have some permanent value out of it, because mostly everything that's happened is available online and will be there for anyone who wants to go back and refer to it. And that's fantastic. So we accomplished a lot of the goals that we set out to do. So that's really exciting. I think you've probably heard news snippets in various places that Software Underground is now, an entity on its own, and so that'll make it easier to grow that, and to have more and better events. And so, everybody here will help make that what it is too. So, thanks for participating in that and just being awesome this week. It's been it's been fantastic to be a part of it, as it usually is. Slightly less tired than I was last year at the end of Transform, but I feel like I've come out of this with even more ideas about where we can take this in the future. So yeah, we don't necessarily have to wait a year before we get together next time. Those ideas about having lightning talks on a more regular basis, like maybe once a month we can get together and do this kind of thing. Share the ideas in the Slack channel, and let's keep the discussion going. And it's fantastic to meet everyone, and I'm looking forward to what Swung is going to do over the next couple of weeks. So
yeah, Filippo, you said, had you forgotten anyone? Yourself, of course, because I can remember after the London Hackathon where you first started organizing what was going to be just a simple hack in Amsterdam to accompany EAGE. We then twinned it with Houston, and then COVID-19 happened, and it became this global event that eventually became Transform. So, dealing with that, I can only imagine made it more complicated. And of course, getting all the sponsors on board, promoting the cafe. Really, Filippo, you deserve a well-earned beer round of applause. And I promise next time we can hang out, I will definitely buy you a drink or 7. Maybe some more maple bacon old fashions.
Yeah, that was missing. Yes.
Yeah. But yeah, just thanks to everyone, of course, who turns up and gives their time. And yeah, you know, Swung is great. Keep it going, pay it forward, stay in touch. Like everyone, I can't wait to see what happens next. I have no roadmap or ideas, but I just have a good feeling that something we turned a corner. This 9 days for me, it was 9 days of hackathon involvement. So, but it's great, and I wouldn't have traded 1 day of that for anything else. So thanks to everyone for making it awesome. And I'm rambling, so I'm just gonna say thanks again, Filippo. You know.
Yeah, it was great. I don't see Matt. I think Matt is not here anymore. Yeah, I mean, you know, if anyone is, you know, wants to share, just, you know, literally anything, thought, you know, it's 1 minute, whatever.
Oh, well, it's just usually this week in June is we're going to spend the whole week traveling and for EAG and all that stuff, and usually tacking on a couple of days of something like this around it. And this has just been such, yeah, it's just a different world in terms of use of time. This is so much better.
Yeah, and
so
you know, I was interested to see how the hackathon would turn out when everyone's distributed. But Steve, your team actually like exemplified what's actually possible with a distributed event like this. Like you literally, it sounded like your team was all over the world, right? And a lot of teams were
all over Europe. Anyway, yeah,
okay.
Yeah. But it had Tony has done non-stop all week, and I think a couple of things that really made it successful is Tony was driving a lot of it, but early on in the week we got GitHub up and running, the issues, populated issues, and got a project board up on GitHub, and I think that made it more easy for people then just to join in because there were already issues sitting there, some marked help wanted, and so it did really work well. But I think yeah, just doing that bit of setup like a proper open source project would early on really made it easier.
Good.
And does Martin want to say something, or he just happened to?
Yeah, no, I definitely want to say something. As someone who's not had the opportunity to get involved in, you know, this sort of stuff in person, the map, you'll quickly see why. I'm a long way from pretty much everybody else. It's been really, really nice to be able to interact with people more and to do some cool stuff. I was probably a little bit over enthusiastic and will now go and sleep for the next week. But yeah, it was really cool to see come out of, you know, essentially a week-long sprint or so to get some really nice stuff off the ground. So yeah, well done to everybody, and yeah, well, thanks for all the interaction in the tutorial channels and things like that as well. I've still got a few of those to catch up on, but it's been a really good event. So thank you to everybody involved and everybody organizing.
Do you want to toot the kazoo to sound the end of the hackathon, Filippo? Or are we closing ceremony?
You should learn how to play a song like. Yeah, I think I'm out of words, out of energy. There is for sure. Probably think it would take me a couple of weeks to collect all the information and like lots of also internal feedback because we definitely spend a lot of energy. And I think for sure the people that like Brandon, Rob, and Matt, and Victoria that took care of the setup for tutorials and so on, there was lots of testing of tools and stuff, so that they definitely we don't want to lose all that work, and we want to sure to make it permanent on some documents that they can reuse in next year. So, and for sure, I encourage everyone to, find a way to keep collaborating. Maybe now that I see that I think that Dieter offered like a nice way, their group to, if you can use similar tools that you, so that you can share your, maybe some planning in between members. I don't know, like keep your weekly Zoom calls to see, how to think and progress. I think that's really, really nice. And definitely, like, probably even the best outcome of all of this is that, in a week, people were able to start something that would continue for much longer. Yeah.
Very good, Filippo. I'll just actually add one thing. I think in a couple of weeks, we'll send out a note, but we'll have a meeting actually about the Swung Society, and pull the community into that. So stay tuned for that. I think it'll be the week after next.
Yeah, that's correct.
So it'd be great to have everyone's input. That's it.
Single building talk sessions. Yeah, Justin. I think we should find a location to put all that together. We actually will soon set up like a repository for the organizations of the society, and that would be like a good location to have like a markdown document just for transfer where you can collect all the most important information about that. Cool. Well, I think it's time to say bye for now on Zoom. I definitely think that what Brent said before would be nice to again try to organize some monthly recurrent meeting or something, talks like that.
Yeah. It's been decided the lightning talks will continue, so I'll do my best to organize them monthly.
Some kind of that people know that put in their calendar, they know that it will happen. Cool. Well, thank you for your time. I wish you all good afternoon or morning or night, depending on your time zone. And yeah, I mean, Slack. We'll be back on Slack and keep our conversation and hacking going on there. Bye, everyone. I think it's probably just easier if I'll land the meeting for everyone because eventually someone will need to do it.
Bye, everyone.
Bye, everyone.
See you, everyone.
Bye.
Bye. Thanks a lot.
Bye, everyone. Nice meeting you all.
Bye, guys. Take care.
Cheers. Thanks for everything.
See you later. Cheers, everyone. Good week.
Thanks. Bye, everyone.
Bye-bye.
Bye.